Good morning, children. In this section, we are going to discuss about the decimal expansion of real numbers. It means how we can represent different rational numbers in decimal form. So, on the basis of this decimal expansion, we are able to distinguish between rational and irrational numbers. Now, you see in this diagram, rational numbers have terminating decimal expansion or rational numbers have non-terminating, repeating or recurring decimal expansion, and irrational numbers have non-terminating and non-recurring decimal expansion. Now, you are unable to understand what is terminating and what is non-terminating. So, I am going to explain you with the help of this example what is terminating and what is non-terminating decimal expansion. Now see, example is find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. So this is a simple division. You have to divide 10 by 3. So when we divide 10 by 3, we get remainder as 1 and the quotient is 3.333 and so on. When we divide 10 by 3, you can observe here, when we divide 10 by 3, 3 3 is 9, 1 is the remainder. So when we put decimal, we can take 0. So again 3 3 is 9, again 1 remainder, again we'll put 0, 3 3 is 9, again 1 remainder, then so on. So this division continues and we observe that after so many steps of division, we get the remainder again and again as 1. So here the remainder is 1 and the quotient is 3.333 and so on. It means this 3 is coming number of times. So the number which is repeating number of times, we put that number, we put bar on that number. So 10 by 3 can be written as 3.3 bar. Now in the another example, you can see second is 7 by 8, divide 7 by 8. So when we divide 7 by 8, you can see when we divide 7, we have to take 0 to make it 70, decimal, 8 8 is a 64, then 6 is the remainder, 60, 8 7 is a 56, 4 is the remainder, 40, 8 5 is a 40. So here you can observe the remainder is 0. But in the first part, the remainder was 1. Remainder was not equal to 0. But here, the remainder is 0. So 7 by 8, the quotient is 0.875. Now you can observe the third part, 1 by 7. When we divide 1 by 7, again you can see 1 is smaller than 7. So we'll take 0 and put decimal. 7 1 is 7, 3 is the remainder, we make it 30. 7 4 is 28, 2 is the remainder, we make it 20. 7 2 is 14, 6 is the remainder, we make it 60. 7 8 is 56, 4 is the remainder, we make it 40. 7 5 is 35, we make remainder is 5, so we make it 50. 7 7 is 49, remainder is 1. Here also the question was divide 1 by 7. So here again 1, again we'll take 0. So this whole process will continue and we'll again get 142,857. So after dividing 1 by 7, what we are getting as quotient 0.142857, again 142,857. Again if we divide it more, we'll again get 142,857. It means 142,857 is coming again and again. So the numbers which come again and again, we put bar on those numbers. So this is again 1 by 7 is equal to 0.142857 bar. And you can observe here again the remainder is not equal to 0. Remainder is 1. So remainder is not 0. Now what we observed is when we divide 10 by 3, remainder is not 0 and we get the quotient as 3.3 bar. When we divide 7 by 8, we get remainder is 0. We get the quotient as 0.875. On dividing 1 by 7, again remainder was not 0 and we are getting the quotient as 0.142857 bar. So from here we observe that when remainder is 0, when on dividing a rational number, when we divide a rational number, if remainder is 0, then it has a terminating decimal expansion. Terminating means When remainder comes 0, then it becomes a terminating decimal expansion. Whatever the decimal expansion come, that comes under terminating decimal expansion. Now you can see in 10 by 3 and 1 by 7, remainder was not 0, remainder was 1. So when remainder is not equal to 0, and those decimal expansions are called non-terminating, repeating or recurring. You can use repeating or recurring, one at a time. Repeating or recurring decimal expansion. Again here 1 by 7, here again the number 142857 is repeating. That is why they are called repeating, because these numbers are repeating. And non-terminating, why? Because remainder is not equal to 0. So that is why both parts have non-terminating, repeating decimal expansion. So we see that the decimal expansion of rational numbers. In this section we have discussed about rational numbers. These all are rational numbers, P upon Q forms. So when we divide these numbers, what type of decimal expansion we get? We are talking about those types. So we see that decimal expansion of rational numbers have only two choices. So in rational numbers, decimal expansion, we have two choices. Either they are terminating, remainder 0, then they become terminating, or non-terminating, recurring, repeating. Non-recurring or repeating, it means remainder 0, then they are terminating. If remainder is not 0 but the remainder is again and again repeating, the quotient is again and again repeating, then they comes under non-terminating and recurring decimal expansions. Or in other words, a number whose decimal expansion is terminating or non-terminating. Suppose if I ask you 3.3 bar, what type of number is this? Is it rational or irrational? So you can see on this 3 we have a bar. It means this is non-terminating repeating decimal expansion. So non-terminating repeating decimal expansion comes under rational number. So it is a rational number. This has a terminating decimal expansion. It means it is again a rational number. Terminating decimal expansion we get always of rational numbers. So in other words, a number whose decimal expansion is terminating or non-terminating recurring is a rational number. So on the basis of this, now you can do exercise 1.3. So this was example 5. Find the decimal expansion. So that we have discussed. Now we are going to discuss exercise 1.3. Question number 1. Write the following in decimal form and say what kind of decimal expansion each has. So in all these parts, what you have to do, you have to divide the numbers and you have to convert them into decimal form, and you have to tell what kind of decimal expansion, whether they have terminating decimal expansion or non-terminating repeating decimal expansion. So I have done two parts. See, the first part is 36 by 100. On dividing 36 by 100, we get 0.36 as quotient and remainder is 0. So now you can easily tell what kind of decimal expansion it has. Remainder 0, then it has a terminating decimal expansion. Second part is 1 by 11. When we divide 1 by 11, we get remainder as 1 and quotient as 0.090909. So the number which is repeating, which number is repeating? 09 is repeating again and again. So we put bar on 09 bar, 0.09 bar. This bar represent repetition of certain numbers. So remainder is not 0, that is why it has non-terminating, and 09 is repeating, so that is why the expansion has become non-terminating repeating decimal expansion. So 1 by 11 has non-terminating because remainder is not 0, that is why it has non-terminating, and 09 is repeating, so non-terminating repeating decimal expansion. Now you can easily do question number 1, 3rd, 4th, 5th, 6th parts of exercise 1.3 yourself. So these are the parts, you can note it down. Third part is 4 1 by 8. Fourth part is 3 by 13. Fifth part is 2 by 11. And sixth part is 329 by 400. So I hope you will be trying these sums. Thank you.